Welcome to the show. Our guest today is the kid next door, teenager, math whiz, and potential video game champion, here to talk about data, graphs, and variables in his efforts to save money for a new gaming system.
That's right. And we're going to show you how changing one variable relates to changes in a second variable.
Remember, in math terms, a variable is a letter or symbol that represents a number that can change.
If I'm saving X amount of money each month towards a $200 gaming system, I can figure out how many months it will take before I have enough money saved.
And he can figure out how many months it will take if he changes the amount of money he's saving.
First, let's make a table with the data, or information we know. We'll let X represent the amount of money I'm saving each month, and Y will represent the number of months. I make $10 per hour at the pizza place. Half goes into my college fund, and I can put half towards the new gaming system. I work 10 hours each month, so X starts at $50 for the first month. If I save $50 each month, the table would look like this after 4 months. So we can see that it would take 4 months saving $50 each month to get the $200 I need for my new gaming system.
But what happens if you don't save as much each month?
Good question. Obviously, it would take longer to get my gaming system. Okay, our constant, the number that doesn't change, is the $200.
Look at you using algebraic terminology correctly.
Video game champions have to know stuff, Mr. Bighead. Now, let's say that I only save $40 each month. The values in our table would change accordingly. By saving $40 each month instead of $50, it would take me 1 more month, a total of 5 months to get the $200. So, changing one variable has an effect on the other variable.
Can we graph that information?
Yes, we can. We're putting the amounts of money along the left side, the y-axis, of the line graph. And we're putting the number of months on the bottom, the x-axis, of the line graph. Now, if we plot the data from our first table, we'll plot a point on the graph where $50 matches up to the first month. Then, continue that line through the point where $100 and the second month match up, and so on, until we show a line going from 0 to $200 and how it relates in time to 4 months. If we plot the data from our second table in a different color, we can see visually how changing the amount of money saved each month also changes the number of months it takes to save the same total amount of money.
Looks like you've got it all graphed out.
It's my destiny, Mr. Bighead. Birds gotta fly, fish gotta swim, future video game champs gotta thwart imaginary aliens.